In lesson 9.4, an ellipse might be along the x-axis or the y-axis with the origin at its center. So that means we're going to have a horizontal or a vertical graph, and each one is going to have a total of 6 points. The horizontal graph is going to have two vertices, and they will be at negative a0 and a0. We will also have two co-vertices, and those will be on the y-axis, and that would be 0b and 0 negative b. And finally, we're going to have two foci, and that is just plural of focus. Our foci will be labeled as negative c0 and c0 on the horizontal graph. Now let's look at the vertical. For the vertical graph, our vertices are now going to be labeled. We're still using a, but now it's going to be 0, a and 0, negative a. Our co-vertices, we're still using b, and it's going to be negative b0 and b0. And lastly, we have our foci, and they're going to be found on the y-axis as 0c and 0 negative c. If you haven't already paused the video and copied down these two diagrams, I think you should. We're also going to go over two equations, one for the horizontal graph and one for the vertical. The equation for our horizontal graph is going to be x squared over a squared plus y squared over b squared equals 1. And our vertical graph is x squared over b squared plus y squared over a squared equals 1. And notice they're almost identical. The a values and the b values are just switching places. Also notice that the a is bigger under the x squared for horizontal, and the bigger a is under the y squared for vertical. And that makes sense, because the a value will always be bigger as the b is closer to the center, and you can see that on the graph. In example 1, you're going to be asked to graph it, find the vertices, the co-vertices, and the foci. And the first thing you should notice is that it's not in standard form, and we just said that the equation should be equal to 1. And those equations on the first slide were in standard form. So because this is not, we're going to have to manipulate it a little bit. There are going to be 4 steps to this slide. The first one is put it in standard form, and in order to do that, we're going to have to divide each term by 100. And when we do that, we end up getting x squared over 25 plus y squared over 4 equals 1. And we can see this is a horizontal graph because the bigger number is under the x squared. I drew a rough graph, horizontal, and we know that our a values, we're going to have a negative a over here and our positive a over here. So if our vertices are negative a0 and a0, then a squared equals 25, then the square root of 25 is 5. So the vertices are going to be 5, 0, and negative 5, 0. Our third step is going to ask us to find our co-vertices. And so if the b squared value is 4, then plain old b, the square root, is going to be 2. So our ordered pairs will be 0, 2 and 0, negative 2. Our fourth step is to determine the foci, and we're going to use the formula or the equation c squared equals a squared minus b squared. And you need to know this. And then we're just going to sub in our values. So we have c squared equals a squared is equal to 25. The b squared was equal to 4. So c squared equals 21. and then we're going to take the square root of both sides, and we'll get our ordered pairs. Be sure you copy down these 4 steps. You had to put it into standard form, determine the vertices, the co-vertices, the foci, and make sure you know this equation. In example 2, we're asked to work backwards. We're given the vertex and the co-vertex, but we're asked to write the equation. I can plot my vertex. I have 0, 4. And if I have a positive 4, I know I'm going to have a negative 4. And then we look at the co-vertex, and that tells me negative 3, 0. If I have a negative 3, I know I'm going to have a positive 3, so 3, 0. And then we're going to draw a little bit of a rough graph here. Because this graph is vertical, we're going to use x squared over b squared plus y squared over a squared equals 1. And for the b squared, we know we have negative 3 times negative 3, so that's a positive 9. Our a value is 4. 4 times 4 is 16 equals 1. And that's our equation in standard form. In example 3, again, we're asked to write an equation. We're given the vertex again, but this time we're given the focus instead of the co-vertex. So I went ahead and plotted my negative 8, which meant I had a positive 8. And for my focus, I have negative 4, 0 and 4, 0. Because the focus and the vertices, they're on the same line, we can see it's going to be horizontal, and I plotted it, so it is. And now we're going to have to solve for b. So we can do that by using c squared equals a squared minus b squared, and we can start to fill in our values. So our c value was 4, so 4 squared equals 8 squared minus b squared. So we end up with 16 equals, 64. 64 minus b squared. We'll subtract 64 from both sides. We get negative 48 equals negative b squared. If I divide both sides by negative 1, we end up getting 48 equals b squared. And then we want to take the square root of both. So the square root of 48, we could use 16 times 3. Find out that the square root is 16, so 4 square root 3 would be my b value if we took the square root of both sides. Now we should have enough information to go ahead and write our equation. The equation we have to use for horizontal is going to be our x squared over a squared plus y squared. You're going to be so tired of hearing this, but maybe you'll remember it. Y squared over b squared equals 1. And then we fill in our values. X squared over 64 plus y squared over 4 square root 3, and that quantity is squared, equals 1. And then we say 4 squared is 16. The exponent is going to cancel out the radical. So our equation turns out to be x squared over 64 plus y squared over 48 equals 1. And I want to take a look one more time at what I did over here with the radicals. So again, remember it was 4 squared, so that gave me 16. The 2 canceled out the radicals, so times 3, 16 times 3, and that's where this 48 came from. Okay, so I hope you took some good notes. If not, you can always rewind.